All right, so I'm going to try and talk through how recursion in this. Sorry, one second. That's going to kill me. Okay, nope, that's still. Okay, all right. I'm going to talk through how recursion in this program works and try to sort of demonstrate visually how the recursive method calls are operating, and then I'll run the program and show you how it works. So first off, just to set the stage, recursion is not necessary anywhere in a program. You can always, I want to be very careful how I say this. I believe it is true that you can always write a program without recursion. However, sometimes recursion gives you a more efficient way to write a program, and very frequently recursion gives you a more a more programmer friendly way to write a program, where it saves you a lot of time and effort thinking about the non-recursive way to write it. So we're going to step through this and show. So what I'm trying to do here is just a simple program that is going to increment an integer until that integer is 10, and then it's supposed to return the integer 10. So I've written our main method here, a driver method that's just going to call two different versions of an add to 10 method. And one of them is not initialized. I don't give it a starting value. And this is to give you an example of how this will happen a lot when you're writing methods, that you'll do something and you'll want this method to call another recursive method. And then here, I'm going to call the recursive method ourself with a different value than this may start with. So down here, here's a sort of initialization method. And when you get to writing a lot of recursive methods, these will become pretty common. So in this case, we call add to 10. And remember that in Java, as with a lot of other programs, you can overload methods. In this case, add to 10 has no now I've forgotten the term for this. Arguments. It takes no arguments. And so if you have no arguments, it's going to call this initialization script method, and it's going to create an integer sum with a value of 0 as the starting value. And then it's going to call the recursive. All right, my cat is on my desk. There we go. It's going to call the recursive version. And it's going to assign the return value of the recursive version to sum after passing in sum. So this 0 gets passed into the recursive method. And then the return value for this recursive method here will get stored in sum, and then we'll return sum. So let's go into the recursive method. And I'm going to walk through all of this, how it's going to run. Once I finished explaining it, but we'll explain this first. So here it's going to receive an integer as an argument. So this recursive method must receive an argument. And once it's received this argument, it's going to enter. It's going to check if the sum is less than 10. So there's a couple of different ways to write this. You could also do if sum is not equal to 10, but I will advise that when dealing with recursive methods, sometimes it's really smart early on to avoid the opportunity of an off by 1 error, because you can quickly end up with infinite loops. And so in this case, since we're doing an increment, we could just make this sum is not equal to 10. However, if somehow we mess up and sum goes from 9 to 11 without reaching 10, then this would just keep going. So by setting it to sum is less than 10, we know we're going to stop if it equals 10, if it equals 11. At some point in our increments, it's going to have to stop, whether we skip 10 or not, but we shouldn't be skipping 10. So if sum is less than 10, that means we haven't reached the position we want to exit at when it's 10. So we're going to jump into this if statement. We're going to increment sum, and then we're going to say send this incremented value of sum. So whatever sum was when we called the method, It is now sum plus 1. We're going to pass that into another version of the same recursive method. We're going to store the return value here in sum, and then we're going to exit our if statement and return sum. Now I mentioned here that this is going to wait for the return of the recursive method call, because this assignment won't happen until this returns. So this runs first, and then the value is stored here. And after that happens, then we return sum. We cannot reach this line unless sum is greater than or equal to 10. Because this is a recursive method, so it's going to call it on itself. So say, for instance, and here I'll go ahead and get this started. All right, we got 10 looks good. Let's make this 14. All right, so I'm going to get started explaining how this works. We'll do transparent. Probably should have put it a little closer there. So to begin with, up here, for the first one, where we do the self-initialization, sum equals 0. So this method here, when it calls, sum equals 0. I'm actually just going to write 0, because we'll know that what we're talking about, and then we'll be waiting. And I need to, this all needs to be smaller, because that's way too big. All right, so sum equals 0, and we're waiting, because we're going to be telling sum to be equal to something else in a minute. And then, so sum equals 0, we pass sum into this method, and we're waiting for this to return. All right, so what is this method? This method here is a recursive method. So we call private static int add to 10 int sum, where sum is 0. If sum is less than 10, 0 is less than 10, plus sum. So 1, my cat is again on my desk. 1 waits for return. So we're going to send 1 into add to 10. So 1 gets passed in. This assignment statement does not happen yet. Instead, it hasn't returned, because so this gets called, but this hasn't returned yet. Same as up here. So this is waiting. This is going to wait. So add to 10, 1. So we're going to do 1 and wait. Okay, so we've called it. So here now, add to 10, where this value is 1. All right, so is 1 less than 10? Yes. Plus sum, so this is now 2. Same thing all over again. We're going to do it another time. So we have 2 up here. Is 2 less than 10? Absolutely. Plus sum. So sum is now 3. And we're going to keep doing that. Now, as you can see here, we went from 0, this was in our not recursive version, to 1 in our recursive version. It's waiting right here. To 2, still waiting right here. 3, still waiting right here. This is going to keep going. I'm going to get, at some point, 9 is going to get passed in. At some point, this is going to be 8 plus, it's going to be 9, and we're going to do 9 and waiting for the result. So I'll put that in here. Hopefully that's obvious how that is going to occur at some point after a few, and I'm just skipping some here is what I'm indicating. So this is 9, so this was 8 when it was passed in. It has been incremented to 9 because 8 is less than 10, and we've done the same thing. 9 goes into here, add to 10. We haven't received any result yet. All right, so the one that was 9, we go up here. It's going to say 9 is less than 10 plus sum. So this is now 10. Now you might think it's done. It is not in fact done, because it's going to throw 10 in here. It's going to say, because we don't jump out, we don't check again. So sum equals add to 10 sum. So sum in this case is 10, and we're going to send 10 in and wait. All right, now 10 goes in here. if 10 is less than 10, that doesn't happen. Okay, that's not true. So we don't go into this if statement. Instead, we jump out of the if statement and we say return sum. So we're going to do return 10. All right, well that seems helpful. This was waiting. It's going to return. Now here we're going to jump over this one. So this one's done. It returned 10. This one here, sum equals, and we're waiting for the return for 10 here. Sum equals add to 10 sum. Well, what did it get returned? It got returned 10. So sum equals 10. Exit the if statement, return sum. Well, we just assigned 10 to sum, so return 10. So this is going to, and now I actually need to adjust this. One second. I'm just going to select this. You'll see why in a second, because this is going to save me some time. All right, so I said we're going to return 10. All right, that's actually not going to save me any time. So back to the drawing board there. All right, so we're going to return 10, and the one that was 9, sorry, that was 10. So it was 10 here. We sent 10 in. That was returned. That was up here because this was not true. So we returned 10. Then this one who had passed in 10 receives back 10, returns 10. The one that passed in 9, so it did 9, sent 9 in. It is now going to receive 10 from this. So now we pass back out that 10. So sum equals 10 at this point, and we return sum. So this one again is just going to say return 10. This will keep going. The one that returned 3, it is going, the one that had 3 right here and had passed 3 in and was waiting. What it's going to receive from the one that was 4, presumably, is 10. So again, just gonna return 10. Same thing with the one that is 2. It's also just gonna return 10. Again with 1. Now in this case, I'm gonna slow down a little bit here to make sure that it's really clear what is gonna happen next. All right, so the one that was 1, this is the first time we call the recursive method. So this one threw 0 into here, and then 0 was received, it was incremented to 1, and then it was passed in here, and it's waiting to receive. And it's going to receive 10, and it is going to return 10, and we are out of our recursive method. That's the end of the recursive parts. Here, sum equals, and this was the first time we called that recursive method, it just returned 10 up here. That was this right here. So now sum equals 10, and we return sum. And so the initialization script here is going to say return 10. All right, and that will be it. This is going to print, and the result at the end of all of this is going to be printing the integer 10. Now I could demonstrate how this will work exactly for -20. In fact, maybe I'll kind of do something similar to that. Just undo all of these. Yeah, we'll do some of the same skips, but I'll show how it starts. So system.out.println add to 10 -20. So the first thing we plug in here is -20. So this is -20, and sorry, I need to put my phone on do not disturb or something. All right, so we have -20. We're going to increment it, and then we're going to pass it in. So this is going to be -20. I'm sorry, -19, because we've incremented it, right? So -19 and wait. and that's transparent. All right, and it's going to call itself. So we'll get this, it'll come in, is negative 19 less than 10? It is. We'll go inside, we'll increment negative 18, wait, then we'll call it again, negative 17, because we haven't done this assignment statement yet. And then negative 16. I hope you do understand like why I'm just saying to do this, because like again, when we passed, we got 16, we sent 16, that was from here, and we sent 16 in, or 17 in. Did it fulfill this? No. So we've called this method after incrementing, and we're waiting on the return. So that's going to happen a bunch of times, because like negative 19 is going to take a while to get to 10. And then at some point up here, we're going to get to 9, just like before. And so 9 is going to get passed in. So one of these will have received 8, just like last time. So it will have received 8. There will be more steps between here, obviously, than previously, because this had a lot further to go. But 9 is going to wait. It's going to pass it in. One of them is going to say, okay, we receive a 9. 9 is less than 10, plus sum. So at this point, 9 is now 10. Again, it's not over yet because we still have to actually get out of this if statement. So it's going to do sum equals add to 10 sum. At that point, it's going to send 10 into this recursive method. And this time, it's if sum is less than 10. Well, it's not. 10 is not less than 10. So we return 10. Now, this might look a little familiar. Because, of course, we kind of know what's going to happen next, right? So this returns 10. This one was waiting. And this 10 is going to be overwritten by whatever is returned. Well, what was returned was 10, so we return 10. And the one that had 9 stored right here. So 9 is going to get overwritten with the 10 that was just returned. And that's going to keep happening all the way down. The one that was negative 16. So it was negative 16 waiting here. So this was 15 before, plus negative 16 is now the value of sum. And now we're saying sum equals, and we passed in negative 16, but at this point it gets 10 returned back out of it. And the same with one that is 17. All right, so the one that is 18. Obviously, I'm pasting it in here already, but I'm going to talk through this one because we're getting near the end. So the one that was negative 18, it had received negative 19. It incremented it. It put negative 18 into here, and it's waiting to receive the result. Well, the result it receives is 10, and then it returns 10. And the very last one, the last one we had called, which had received negative 20 originally when we called it up here. So it was negative 20. Negative 20 is less than 10, so we go into our if statement, plus sum, so it's negative 19. Sum equals add to 10 sum. Well, it sent negative 19 in, but it's now waiting to receive the result. And it's received the result from all the way back at the end, like after all of these have run. And the result is 10. So sum equals 10. It's been waiting this whole time, just doing nothing, chilling. So return 10. I kind of jumped ahead of myself slightly because what actually happens is 10 is what it receives from right here. So the return 10 happens right here. It's assigned to sum, and then we return sum. And in this case, there was no initialization method used. We called it directly. We called the version that is our recursive method actually. So it just returns 10. So this should end up printing 10 as well. These two should end up printing exactly the same thing. Now I do have these saved here. So I'm going to do Java C recursion demo.java. All right, so I've compiled it, and then Java recursion demo. And what we should get is just 2 printouts of 10. And there they are. Yep, that worked. Okay. I don't have too much more else left to explain. Again, there's plenty of ways to write this that does not involve recursion. I chose this one because it's pretty easy. Like, all right, if you want to take an integer and increment it up to 10, you could do that in a simple while loop. You could do it in a for loop. But if you want to do it using recursion, this is a simple example of how it works. Hopefully this was helpful. Let me know if you have any questions, and I'd be glad to answer them.